Hi there, what I want to talk today in this video clip is about the law of conservation of mass. It simply states that the number of atoms in the reactants is equal to the number of reactants in the products. Suppose I took something like, let's say, calcium carbonate, chalk. Here's calcium carbonate, CaCO3. If I heat a carbonate, it forms an oxide, calcium oxide, plus liberates carbon dioxide gas. I've done an experiment and I find that I have, for example, 28 grams of calcium oxide, and I had 22 grams of carbon dioxide liberated. How much calcium carbonate did I start with? The answer is the products was 50 grams, so therefore the reactants was 50 grams, i.e. the mass of the reactants is equal to the mass of the products. Let's look at a second example. Suppose I say I've got, this time take copper carbonate, CuCO3, I heat it, it's thermally decomposed to give me copper oxide plus carbon dioxide. Now I say to you, well, and I do the experiment and I start off with 8 grams of copper carbonate. I'm left with, say, 5.15 grams of copper oxide. How much CO2, carbon dioxide, was liberated? It's common sense. If I take that one from that one, that is, it's 2.75, sorry, can't count, 2.85, so this 2.85 grams of carbon dioxide. Again, reactants, products, 8 grams, 8 grams. So I'm simply trying to show that in any reaction the mass of the reactants is equal to the mass of products. Let's take that copper oxide again, copper oxide, and I heat it, and I know this, I get copper oxide formed. Will this weigh more or less? The answer is this will weigh more than that because the copper has reacted with oxygen from the air to give you that product. So the reactants will be the same weight as the products. If I took a piece of magnesium and I burn it in oxygen, it forms magnesium oxide, which will weigh more. That will weigh more than the magnesium because its reactants, magnesium and oxygen, gives you magnesium products, but the masses would be the same. I want now to look at a more complicated example. Let's look at good old calcium carbonate reacting with hydrochloric acid, HCl. Acid plus carbonate gives you a salt, calcium chloride, plus water H2O plus carbon dioxide. So acid plus carbonate gives you a salt, water and carbon dioxide. Here's the reactants, there's the products. Let's calculate now the relative masses, formula masses of each of those constituents. I got calcium carbonate is 100, hydrochloric acid HCl is 36.5 plus 2 times 36.5. That's the reactants. And calcium chloride is 111 plus 18 plus 44. And that totals 173. And that is 173. Mass of the reactants, number of atoms in the reactants, equals the number of atoms in the products. And how did I calculate that? 100, in the previous video clip, I explained how to calculate the relative masses, molecular masses. For example, let's look at that one again. Calcium, 40 plus 12 plus 48. Hydrogen chloride, hydrochloric acid, 135.5. Remind you again, calcium, 40, chlorine, 35.5, hydrogen 1, oxygen 16, carbon 12, oxygen 16. And that is basically the law of conservation of mass. I'll be looking at concentrations and more on weights in the next video clip.